Good morning, friends. I welcome you all here for my course Aircraft Systems. It gives me immense pleasure to take the topic of aircraft engines. You know that I am Dr. Yagya Dutta Dwivedhi, professor from Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad, India. As of now, I am in the process of describing about problem solving and the case study zone of my lectures. Till now, I have done 52 or 53 lectures. This is the 53rd one. Hope you have seen the previous, and today I am going to discuss about aircraft engines. So please be tuned and understand this topic. Topics and the CO mapping. So here I am going to talk about aero engines, and this is the part of the course outcome of the three types of aero engines, CO3, gas turbine engines and types, also CO3, combustions, oxidizations, and the case studies of different types of engines. So, importance of the aero engines. We know that every aircraft has to be worked with the engine only. If the engines are not there, the aircraft is not going to work properly. So, why would we want to know about aircraft engine? What is the necessity to learn about the engine? You know that for any locomotion, let it be ground locomotion, maybe scooter, car, bike, aircraft, trains, ships, everywhere we need the engine. Because without engine we cannot move, because the thrust which is achieved is obtained from the engine itself. So the engine is a key part of any airplane, counteracting the force of drag and creating the speed necessary for lift. It is important to understand aero engine in every aspects of the aviation industry. Also, it will be important to know what is the class. So you will be more prepared when we add more complex detail in the next few classes. So we should understand that for an aircraft, the engine thrust has to counter the drag. But if you want to take off, you need a sufficient amount of velocity. This velocity we can get only from the engine. Engine will move the aircraft forward, and due to this motion, you will get a sufficient amount of velocity, and this velocity will make sure that your aircraft is going above this thing. Just I will show you here. Okay, this is the aircraft, and this is the engine. This is the engine. So this engine is producing the thrust, and this thrust will go from here, and a jet will be produced, and aircraft will go opposite direction. This thrust is required to counter the drag which is produced by total aircraft. That is the first and primary requirement. The secondary requirement that the wings are to produce the lift. So this thrust should be also able to give the velocity of the aircraft in such a way that the lift is produced, and this lift, we know that lift is equal to L is equal to half, this you can see here, L is equal to half rho V square S, where S is the area of the wing, V is the velocity of the aircraft. So this area is fixed. So this lift should be more than weight. Then only your aircraft will be able to take off. So we need, as per the weight, we need the lift also more and more. So this lift will be produced from the velocity. And from where we will get the velocity? From this engine. So if engine is able to produce the thrust in such a way that it is able to counter the drag forces, and also it is able to generate the lift upward direction which is able to counter the weight of the aircraft. Minimum lift is required equivalent to weight. But in all operating condition, lift should be much more than the weight. So the load factor of the aircraft, mostly they are, for the passenger aircraft, they are 3 to 5. And for the fighter aircraft, this goes to 10 to 12. So means lift should be, if it is the load factor is N is equal to L by W. So if N is equal to 3 means lift is equal to 3 times of the weight. For any aircraft, minimum this is the condition required. So that much amount of weight, if it is there, if more weight is there, you need a 3 times more lift than the weight. So we should be very much cautious whenever we are designing the aircraft. The weight reduction is very, very important, and every designer has to think about the weight of the aircraft. So here, very much essential to important to know that which class of the engines are used for the aircraft, and this I am going to discuss in our class. And here I have shown the 2 aero engines. It is a turbofan engine, the first one, turbofan, and this is the turboprop. Not turboprop, it is a piston turbo, piston prop. So one is the piston engine, another is the turbo engine. So this we have to understand. Now engines. Engines are used for the propulsion of the aircraft. So we have 3 main types of engines. One is the rocket type engine. Then we have the gas turbine engines. This includes turbojet, turbofan, ramjet and the turboshaft engine. Then we have the piston engine. They are the old type of engine and they are called the piston engine. So this you can see here, it is a piston engine here. And this is the turbo engine. So these 2 engines are shown. So we can classify this aero engine into 3 groups. One is the rocket engines, another is the gas turbine engines. These gas turbines may be turbojet, turbofan, ramjet and the turboshaft. I am going to discuss each and every one in this coming slides. Then we have the piston engine. First I will discuss about the rocket engine, and this you can see here that we are having the rocket engine here. In this, the thrust is used for this purpose. This is the schematic diagram of rocket engine, and by far the simplest propulsion method, one of the least common and certainly the oldest rocket burns fuel in a controlled explosion, throwing exhaust gases back and pushing the engine onward. So this you can see here, we have, this is the rocket engine here. And what are the components here? We have the one fuel tank is here, one oxidizer is here. So this fuel is coming by this way. Here is the pumps. These pumps are giving high pressure, and here is the oxygen is coming from here. Both are mixed here in the combustion chamber. This is a combustion chamber, and from here this is expanded in the nozzle, and here is the exhaust. So VEPE, and here is the atmospheric pressure is here. This is the exit, and this is the inlet, and this is the throat of the nozzle. So here this we can see V is a velocity, m dot is a mass flow rate, and P is the pressure of the system. So a simple rocket engine is shown here for the discussion. The earliest known form of the rocket was a black powder rocket used to power Chinese fire arrows. In 400 BC, they used to have this. You can see here in this rockets. Rocket engines have the advantage of not needing air to burn. So in the rockets, we don't need air to burn because air is contained inside. They also have a minimum lag on command and good acceleration. They are not very fuel efficient. Okay, so these are the something. These rockets can go above the atmosphere where air is not there, because air, we don't need the air. Air is contained, oxygen is contained inside itself, and it is giving a very good acceleration, but it is not a fuel efficient. Means more fuel is required to get this thing. Nowadays, rockets are used principally for space exploration and the launching satellites. Rockets and most engines requires Newton's third law of motion, action and the reaction. When one body exerts a force on the second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction of the first body. So this is the Newton's third law. So these things are working with the help of Newton's third law, action and the reaction methodology. Now, piston engine overview. So I will discuss about the piston engine and how the piston engines are working in this. So piston engines are the most popular engines. They can be found on many planes, cars, helicopters and the hovercrafts. And it is shown here as a radial engine with the propeller is shown in this diagram. The first aircraft by the Wright brothers were also used the same piston engine. Piston engines were invented in the late 19th century. They were readily available, if not somewhat unrefined, to Orville and the Wilbur Wright, who used one in the 1903 flight of the first flyer. So in this first flyer, it is called the first flyer, the aircraft which is from the first time, and this was used by the Wright brothers, Orville and the Wilbur brothers, and they have used the piston engine in 1903 December in Kitty Hawk, USA. And the image is shown here. So, continuation of this piston engine. The piston engine is one of the more complicated way to get an aircraft moving. So, complicated, the piston engines are very complicated because they have a lot of valves, the pistons, cylinders, motion, converting the reciprocating to the rotary motion. So, it is much complicated than the turbo engines. It works by burning compressed fuel and air together to push a piston that connects to the powertrain, where it is eventually transferred to the propeller, or in the case of helicopter, the rotor. Piston engines are categorized by their capacity, piston layout and number of the cylinder. This you can see here, the number of cylinders 1, 2, 3, 4, 5, here 6. So like this, here we have the 6 cylinders here, and it is the valves are here. This is the inlet valve, this is the exhaust valve, and here is the piston, this is the cylinder, this is the crank, this is the crankshaft. So like this your engines, piston engine will have. So, and here you have the valves, spring loaded valves. They will operate in such a way. Now I will discuss about overview about gas turbine engines and overview. So in this we can see that the somewhat crude form of the jet is shown here. The ramjet is a tube with fire in it. You can get going very fast. The ramjet requires high speed to start, meaning it can't be still. So this is the ramjet, and to fire this ramjet we need speed. So in a certain amount of speed, and this speed should be more than the sonic speed. So this is used for the missiles and all, air to air missile, air to air missiles. These systems are used, and air will enter here and it will be compressed by this thing. Then fuel will be injected here. Here is a flame holder. Here this flame will be held up and it will go to the nozzle, and here in this nozzle M will be exceeding more than 1. So this is a simple gas turbine engine or ramjet engine. It is not a gas. So here I will talk about the second one is a turbojet. It's a kind of complicated to explain. Let's look at the picture. This you can see here that how just I am going to explain slowly. So here this you can see here that air is entering from here. These are the compressors. We have many stages of compressor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here it is shown the 17 stages of the compressor. Okay, so it is simple turbojet engine. So you can see the area is also tremendously reducing. So initially the area was this much and this much. Now it is only this much and this. So that much volume is compressed to this much. So that is called the compression ratio. To have the more compression ratio, we need the more number of stages. Each here I have shown here 17 stages of the compressors are available here. So as air is entering and it is rotated, air is compressed. As it is reaching to the combustion chamber, the high temperature and the high pressure gases are entering in the combustion chamber here. Fuel is injected here. Due to injection of the fuel, the burning is taking place in the combustion chamber. This hot temperature and the hot pressure is entering in the turbine. These turbines are moved and this turbine will give the power. It may be in the nozzle, it is a jet. So this will give, flow will be in this direction. Your aircraft will move in this direction by Newton's third law. Okay, so the intake fans like in air, then it gets compressed in the compressor. It then gets combined with the fuel in the combustion chamber. Before being expelled, the hot air leaving push the aircraft forward, but also spin the turbine blades, which drives the intake blades. So these turbines are also rotating. These turbine blades are rotating the compression. So that is the function of the turbojet engine. Now, in some modern aircraft, we have some afterburner because we need some additional thrust. In case of emergency, we want, so here we can edit some additional fuel after the turbine. So we can inject fuel directly into the exhaust to create a bit of boost. We call that an afterburner. As you can imagine, it is not that fuel efficient. So it is not that fuel efficient, but we need some special tank, fuel tank, and this is not the normal fuel, some special methanol or something, and these fuels are injected after the turbine before the exhaust nozzle. So additional thrust is produced. These thrusts are very useful for the fighter aircraft to run away from its requirement. The speed of the aircraft will be much more high. Okay, so like our fighter MiG-21 and all, they all have the afterburner to use in case of emergency. It is only for a few minutes, and in these few minutes it will be very fast comparing to its maximum speed. Without it will be some 1.5 times speed of the aircraft will be increased. So you can escape or you can do some maneuvering if you need some additional power in that type of situation. Now I am further going for the gas turbo engine or gas turbine engine. Continuing, okay, these are the aircrafts where normally we use this gas turbine engines. This you can see here. Here, these are the aircraft which are having the gas turbine engines. So turbojets are commonly found on military aircraft, small civilian jets, and older commercial jets. Older because nowadays we use the turbofan, not the turbojet. Pros, the good thing about this is good high speed and the medium efficiency. The disadvantage is loud, sound is more, and high control lag due to spool up and the down. So here is some lagging of the control. This is also called a low bypass jet engine. This is also called the low bypass jet engine. So these are the some pros and the cons of the turbojet engines. Now I will talk about the turboprops engine. Turboprops means the aircraft which is operated by turbine system with a propeller as a thrust producing device. So this is called the turboprop. So now imagine the engine we just look at, but in front of the intake fan we attach a propeller into the turboprop. So this you can see, all things are here same from here to here, only we have added this propeller. So if you add this propeller, this is shown in this aircraft, so it is called the turboprop engine. Everything is same except the nozzle is removed. In place of that, propeller is fixed. This propeller is sucking the air and giving the air behind, and aircraft will move forward. So principle is same, action and the reaction, but here we need one gearbox. This is also one gearbox which is not in the previous, so the efficiency of this thing is reduced, and also there is a propeller. So what are the good thing? Good engine response and much quieter. It is not that much sound producing machine, better than the turbojet. Good performance at lower speed. The speed of this aircraft is, the performance of this aircraft is good for a lower speed, some 0.5 Mach, 0.6 Mach like this. It is very good, 400, 500 kilometers per hour. Good fuel efficiency. It gives much better than the turbojet engine. What are the drawback? Not as fast as the speed is not that much. Can't operate at high altitude, and it is not good for a high altitude operation. Commonly found on the medium airplanes of the almost any type. So these things are used still in so many aircrafts because it has got the better fuel efficiency. So most of the commercial aircraft they use, if they are flying at a low altitude and the range is also requirement is less, that time they use turboprop engines. Next is very important type of engine is turboshaft. This turboshaft engine is mostly used on the helicopters. A turboshaft is a turboprop with the drive shaft extending from the engine and going through a gearbox, so that the speed of the shaft is not necessarily tied to the main engine. We see this a lot in helicopter. So this turboshaft, what happened? This shaft is driving a gearbox. From gearbox, one goes to the main rotor. This is the main rotor, and another goes to the tail rotor. So it is not directly related, but it goes to one gearbox. From that gearbox, it is taken upward for the helicopter main rotor blades, and in behind it is operating the tail gearbox. Or if it is a tandem type of, for each aircraft, for each rotor we have a separate engine and the gearbox is operated accordingly. So these are the turboshaft engine. Nowadays this engine is used everywhere. It is the turbofan engine. It is now much better than the previous turbojet engine. And so turbofan, the intake fans of the turbojets are extended, and the air passing through this extension exits the back of the engine without being burnt. This is called the high bypass engine. So the normal jet was the low bypass, but here we have the high bypass engine. Here this you can see one additional fan is added here. These are the compressor here. Before that one fan is added. And this is called the high bypass ratio engine. It is much fuel efficient, a bit quieter, and produce much more thrust of its weight. So it is very good. In sound is producing less, and thrust is much with its weight. Thrust to weight ratio is very high. We see this on the modern commercial jets for its tremendous advantages. Most of the commercial aircraft, they have started using this high bypass ratio turbofan engine. However, nowadays your fighter aircrafts also started a medium bypass ratio turbofan engine, because it gives size is reduced weight is reduced, the sound is also reduced. So it is like Rafale engine and all, we use the medium bypass ratio turbofan engine. Now we have to see next is the combustion. We have seen in all the engines, we have seen that there is a fuel and this fuel has to be burned. For different systems, we have the different types of burning mechanism. We have seen first rocket, we have seen the piston engine, we have seen the ramjet engine, we have also seen the turbojet engine, and everywhere if you see, their heat is obtained by the burning of the fuel. This burning is called the combustion. This combustion has to be burned at a certain amount of temperature and the pressure. Then only an efficient burning will take place. Fuel and air explode in a process called the combustion. The capture and the direction of this explosion is where we get our engine power. By this explosion, only we are getting the power for the engine. In each engine, it happens in a different location. If you see here, this is the turbojet, this is the ramjet, this is the piston engine, this is the rocket engine. So, first I will discuss about the turbojet. The location of the turbojet is, we have the rotary compressors. These compressors are compressing, air is sucked from the inlet. This sucked air is entering and pressure is raised. This high pressure will go to the combustion chamber. In this combustion chamber, air is burned. This burned air is entering in the turbine, and this high temperature and the high explosion which is taking place, they are rotating this turbine and this is expanded in the nozzles and thrust is achieved. So this is the principle of combustion for the turbojet engine. But if you see the ramjet engine, the combustion is somewhat different. Here there is no rotating part, air is sucked by the velocity itself of this, and there is a passage. This difference in the area will increase the pressure. This pressure increase and the temperature increase will enter here. Fuel is injected and here the combustion is taking place from here to here. This is the combustion zone. There is no separate equipments. It is, and the high temperature and the pressure gases are entering outside, exiting, and they are generating the pressure or the thrust of the engine. If you see about the piston engine, in the piston engine we have here the piston, then it is a cylinder. There the fuel is coming from here. As it is going downwards, fuel is sucked inside like this. After reaching here, all these valves are closed and it is compressing, and this high compression air, fuel is mixed here, and then it is, spark is given and ignition and explosion is taking place. This explosion will make this thing to move backward, and here the crankshaft is there and it is rotated and power is transmitted from here. So in this way your piston engine is working. But about the rocket engine, in the rocket engine it can go above the atmosphere where the air is not available, oxygen is not available, because we carry the fuel and the oxygen inside. So here the blue color is the oxygen cylinder and here is a fuel tank. This fuel tank goes to the pump and oxygen also goes to the pump. Both are sent to the engine, rocket engine. Here it is ignited and the high pressure and high temperature velocity is going from the nozzle and the body will move further. So the combustion is taking place in a different way for the different types of aircraft or engine, and it is shown in this slide. So there is a difference between fuel burning and fuel exploding. Burning alone is like a candle. This you can see here, it is a burning. Like your candle, but this is the explosion. Okay, so there is a difference between fuel burning and fuel exploding. Burning alone is like a candle, it works, but it is slow and doesn't work very well in engine. So if it is just like you are burning like a candle, it will not give sufficient power. When combined with a specific mixture with air, we get an explosion, something with which much more force, much more capable of moving things like airplane, getting more bang for your fuel, which can be up to $7 per liter. Okay, so I can't tell these all things. Next, we will see about the oxidization. Oxidization. So, oxidization is a process of getting the air into the engine. So, how we get oxygen for the engine? So, the process of getting oxygen for the engine, we say that it is a oxidization process. So, if you see the piston engine, the air is brought through an air intake by the natural vacuum of the piston and the airflow of the aircraft speed. So, the air is brought through an intake by the natural vacuum of the piston and the airflow of the aircraft speed. Okay, so this you can see the oxidization, the air is entering here, air is entering here. In this way, oxygen is obtained to burn the fuel inside the engine. Okay, so that is the oxidization is taking place by this way. Oxidization here also, oxidization is the process of getting the air into the engine. So how we get the air in the rocket? So in the rocket, if you see here, we have stored the oxygen, and this oxygen mixing with the fuel by the help of the high pressure pumps. These pumps are pressurizing and we get this thrust, and this is schematic of flight of the okay, so these are the references are given here. So this, because space has none. In space we don't have anything. We cannot fly our aircraft. So there your action and the reaction will work, and there your rockets are used, and this is the principle for oxidization of the rockets. Here also oxidization is shown here for the experimental analysis. In the testing of your rocket engine, this thrust burning of the fuel shown here, and how much thrust it is generating, and oxygen is coming from this side. So on gas turbine engine, the air is brought through the front intake and into the engine. So this is the intake, air is entering here. This air will go to the compressor. From here it will go to the combustion chamber, it will go to the turbine, and here it will go to the nozzle, and this will go like this. So in this way your oxidization is taking place in such type of engines. Now these engines are used for different purposes. So some, I have shown here some aircraft. These aircrafts are using the different types of systems. So here a radial piston engine. So here is a piston, propeller engines are used. These engines are used and they will get the thrust. Here it is a turbojet engines are used. Turbojet, which I have already explained you in detail about this turbojet engines. Nowadays we have the turboprops engines. So many aircrafts we are using the turboprop engines. Military aircrafts, the cargo aircraft, the passenger aircrafts, they are very efficient in the low altitude and low range aircraft, the fuel consumption of the turboprops are very less comparing to the turbojet. So for short haul and low distance aircraft, low altitude range, we use such type of aircraft which produce the very good result. Next we have the helicopters. Here we use the turboshaft engine. Most of the helicopters are using the turboshaft. They are very light in weight. They are very efficient for the helicopters. Their size is also very less. So turboshaft are used for this purpose. Now this modern aircraft, they use like Airbus 320. They use the high bypass turbojet engine. They are using such type of engines. Engines are super important to everyone in aviation, from designers, ground crew, fuel makers, mechanic, pilot, and even passenger. Hopefully, this class has queued up your interest in this ever advancing topic. Right now, major corporations are working on electric, hydrogen, and the hybrid engines in the aviation field. So, what I want to see is that the very interesting topic of the engine, and everyone want that engine should be there. But now the petroleum products are diminishing from the earth. We need some new type of engines. So electric engines, hydrogen engines, and hybrid engines, nuclear engines are also to be developed for the aircraft purpose, and that may be very useful. So we all have to think about the new development, new research on this area, so that we can develop the very efficient, low-cost aircraft in the future. These are the references I have taken from this slide, and then Moir and the Seabreeze, Design and Development of Aircraft Systems and Introduction. Any questions, you are welcome to ask. I am ending here my session. This is my email, @gmail.com. This is my email. Hope you all will like this lecture. Please subscribe and also like this video. Thank you very much. Be tuned for my next lecture. Shortly, I am going to give the next lecture. Thank you very much for the joining. Shobha Khair. See you soon. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.